dear students. We are in the series of quantum technology, and in this series we are discussing the energy storage devices in a flexible mode. Means we are discussing the wearable electronic devices, that is the energy storage, flexible energy storage devices. In the last lecture we have defined the various electrodes, how we prepare the electrodes, how we prepare the electrolytes, and what are the fabrication techniques. In the continuation we are discussing the one of the another technique which is used for development of energy storage devices, that is in the flexible mode. So today we will discuss the some remaining flexible energy storage devices development techniques. In this, first we discuss the chemical vapor deposition, that is CVD. This is one of the method to grow the electrode material inside a furnace by using the precursors on a catalytic surface. So CVD has a high yield and is capable of achieving the industrial production of electrode material, but direct growth of on the plastic polymer surfaces at a high temperature and selective growth are some challenges in the CVD. So enveloped the supercapacitor electrodes of the three-dimensional graphene on the flexible graphite paper substrate, a high quality 3D graphene powder grown by the CVD, which were uniformly deposited using a straightforward and the quick self-assembly method. So at a power density of the 178.5 at the paper based symmetric supercapacitor SC demonstrated an impressive energy density of amount 8.8 with a peak capacitance of 260 in the 3 electrode configuration and 80 in the full cell setup. So even under the bending, rolling and twisting condition, these flexible supercapacitor demonstrated exceptional performance, underscoring its superior flexibility. You can see on the screen, this is the method how we code the various devices. Now you can see there is a deposition method. First we are having various SO2 wafer, then on the wafer there is a deposition of the CNT. Now you can see on the screen that is a vertical alignment of CNT. So we can prepare the 3D printed magazine based supercapacitor and its device performance. Now that employ the CVD to grow the vertically aligned CNT, that is why it is called a VACNT, and subsequently transfers them into the MONI by layers. Means we are having a wafer, on that MONI we are having a layer of that, and on that layer we grow the VACNT, which were facilitated using the CVD method with the iron aluminum catalyst. So VACNT integrated with the MONI bilayer, and that could be readily peeled off from the SiO2 wafer. So silicon wafer is used for deposition of the VACNT after growing on the bilayer. So allowing the transfer the printing of the nanoparticles onto the polymeric and elastomeric substrates by taking advantages of the weak adhesion of the nickel and CiO2. Means we are just transferring and we are using the advantage of polymeric and elastomeric substrate, as these are all flexible and these are variable. So we use the development of the VACNT growth on that substrate. Furthermore, the presence of MO layer facilitated VACNT growth, while the MONI bilayer beneath optimized lateral current flow. So we developed the electrode exhibited an aerial capacitance of approximately 4.6 during the initial cycle, and even after the 1000 cycles the additional 4.2 capacitance was still achieved. Another method is the three-dimensional 3D printing. So, in the 3D printing, that is the thought to be an alternative methods that can satisfy the need of high performance and flexible to produce the wearable electronic devices. It has drawn an attention of the more researchers because of its ease to use and controllability in the fabricating a variety of structures on adaptable substrates. So, the extrusion based 3D printing can build intricate energy storage structure fast, efficiently and waste free. So, in contrast to alternative 3D printing method, direct ink writing printing technology produces high performance 3D structural energy storage devices faster by directly extruding ink through the nozzle and deposited it on the substrate layer by layer. So, by using the ink, the structure of the energy storage devices can be developed by depositing the ink through the nozzle. So, moreover, the advancing the 3D printing technology, particularly the DIW mode, has considerably bolstered the capacity for designing and precisely controlling the microstructure of the devices for flexible electrochemical energy storage. So, demand of wearable energy storage devices concerning the size, configuration, efficiency and seamless integration are efficiently met by extrusion 3D printing technology that enable the rapid fabrication of flexible electrochemical energy storage devices that is characterized by the slim profile, lightweight construction, intricate structure and superior performance. So, whenever we develop the wearable energy devices, we keep these parameters in mind. One of the paper in Yon, he decided and he demonstrated the direct 3D printing of quasi-solid state symmetrical supercapacitor. So, using the aqueous magazine, sedimented ink and eliminating the need for additives. So, the direct ink writing technique permits the printing of supercapacitor with various architecture at the room temperature by adjusting the concentration of magazine. That magazine has been used for the direct deposition and that is in the form of the ink on the substrate and achieve the desired viscosity. So, with the peak areal capacitance that is of the 2.3 and areal energy density that is 207 and that has the power density that is 374 and the capacitance retention exceeding 93% after the 10,000 cycle. So, the study that has been done by the researcher revealed that the 3D printing M.Sc possessed commendable charge storage capability. Now, you can see there is a magazine sediment that is in the some of the nozzle and that is transferred in the injected nozzle and that from this nozzle it is just used to draw the structure of the energy storage. You can see easily on the screen that there is a one type of electrode. So, these electrodes can be used for the energy storage devices and other electronic purposes. If you see the structure, then you can see there are the various ions like various electrolyte ion and then we can use as an energy storage devices or as a supercapacitor. So, when coupled with the 3D printing technology, the use of waste free magazine ink is manufacturing supercapacitor that present a viable option for fabricating the wearable and portable electronics and that electronics can be used in the sensor as well as in the energy storage devices. So, there are the some fabrication techniques like electrophotic deposition, electrolyte deposition, so and plasma etching and that has been limiting use for development of wearable supercapacitor. So, other widely explored fabrication techniques like printing in which we are having the screen printing, we are having inkjet printing, we have spray coating, that is also one type of the printing. We are having the wet spinning, electro spinning and electro deposition, that we also use for the fabrication of the supercapacitor, that we will discuss in the further. So, in the smart wearable flexible textile based energy storage devices have immense application in the wearing field. So, in the further lecture we will discuss about the textile based energy storage devices, that is having the various application in the various field. So, it is ranging from the healthcare monitoring system to the military. Healthcare, where we are having the toxic free environment, moreover it must be flexible. We use it also in the electronic components for the smart devices. So, flexible textile based energy storage devices have immense application in the various fields. So, it is also a wearable, as it is using the textile. So, it is also a wearable, that is a wearable electronic devices, and the smart conductive textiles are newly emerging field with the term smart wearable. As there is advancement in the technology, technology is changing day by day. It is not a need, it is a necessity, and it is advancement. So, we have to update with our research. So, in this we are using the smart wearable flexible textile based energy storage devices, which can be directly worn on the body or integrated into the clothes. So, the development of the flexible supercapacitor has been greatly aided by a growing demand for high performance energy storage system to power smart wearable devices. So, it is a main duty or main function of the flexible supercapacitor that it can just provide the power to the smart wearable devices as well as the electronic devices which is developed by the printing technology. So, owing to flexibility and the comfortability, people feel wearing them all the day and making textile fibers as ideal platform for wearable electronic devices. So, in near future we can have our various electronic gadgets on the cloth, and it can directly print on the wearable cloths or the textiles. So, the combination of the energy storage system together with the other electronic components play an important role in developing the smart, flexible, textile, electronic application. As we talk about the supercapacitor, so supercapacitor based on textile fabric have been advanced due to their lightweight, flexibility, good electrochemical performance and cost effective, moreover toxic free. So, it should not be toxic. So, flexibility together comes with terms like stretching, bending or any other deformation that does not surely affect the electrochemical performance. As we are using the flexible devices, so it will move with the body, and as the body move and we are doing the stretching or bending or other deformation, these devices should not compromise with the performance as they are used in the flexible environment. So, its potential to be used with the new and advanced active material, its performance will be good. So, flexible and portable electronic devices and healthcare monitoring devices recommend the utilization of energy storage devices like supercapacitor, which provide the enhanced energy storage capability in order to thousands in the same volume in comparison to the batteries. So, in place of the batteries we use the supercapacitor, and that supercapacitor we use on the textile, and on the textile we print these supercapacitor, and if it is printed on the supercapacitor, now they are wearable, moreover they are flexible, they give the good performance after the bending, stretching or the deformation. So, although we talk about the batteries have remarkable energy capacity, but they suffer from the problem including the low specific power, poor cyclic performance and reduced charge discharge cycle rate capabilities. So, whenever we develop the supercapacitor for the flexible electronics, so it must be having good performance for the charge and discharge cycle. So, in contrast, electrochemical supercapacitor can withstand more cycles with improved Coulombic efficiency and offer the long charge discharge cycling stability. Once it is charged, then its discharging rate is very slow. So, one of the parameter fast charging and slow discharging. So, improved and more flexible energy storage solutions are needed in the design and development of contemporary smart wearable technology. So, cotton or polyester fabric are pressed or woven to create the textile which are pliable, porous material, and on that we can just create the supercapacitor. So, creation of stretchy and wearable electronics may benefit from the functionalization of the textile using the nanoscale material to make them conductors. We have to make the conductors. So, fabric fiber based materials are widely researched as the potential candidate for an alternative to conventional counterparts due to their lightweight, flexible and economical properties and can be transformed into any shape and structures and integrated into miniaturized flexible wearable electronic devices. So, flexible textile providing the stiff and unyielding textiles, incorporating textiles into flexible system into the textiles provide the seamless integration of the energy system into the textile. So, it is the main focus of the research. So, first generation planar solid state supercapacitor relied on metal substrates. Which metal substrates we will use? We use the copper mesh as well as the nickel form. So, these metal as we have already discussed regarding the solid state supercapacitor. So, presently for this these are the suitable for the flexible electronic devices. So, these metal contact substrates provide the good electrical transfer of the charges. So, however, they were rigid to use the flexible and wearable applications. So, developing flexible batteries and supercapacitor not only relies on the delivering and holding the energy and power, but also retaining the structural properties like bending, stretching and deformation. So, supercapacitor integrated into the wearable devices are found to offer a good power density and the specific capacitance. The same properties and same parameters we require for the flexible, like we require the good power density and the good specific resistance whenever we integrate the supercapacitor into the flexible wearable devices. So, this kind of wearable supercapacitor device is utilized to power the healthcare monitoring devices and the sensor at the same platform. So, flexible materials like polymeric film, yarn, fabrics and papers are now being studied to be used as substrate as they provide integrity with the electrode material. So, the major drawback of the supercapacitor energy densities and the density withstanding capabilities. There are the various references from which we can have the methods to preparation of the supercapacitor that can be given in the reference section. So, which can be overcome by utilizing the fabric method and the material, and more efficient design patterns are required and various fabrication methods, materials including electrode materials, substrates and electrolyte which could be utilized in the wearable supercapacitor. So, what is the textile substrate in the textile supercapacitor? So, first need is the substrate. So, what type of substrate we can use in the super flexible supercapacitor in the textile. So, textile based supercapacitors are very appealing for the next generation variable electronics because they combine with the energy storage characteristics of the supercapacitor with the comfort, with the flexibility and variability. So, textiles in the use in the unique way. So, textile substrates are widely utilized in the variable supercapacitor due to their inherent flexibility, breathability, lightweight and mechanical adaptability that make them ideal for integration into the garment or on skin electronics. So, widely used textile materials include natural fiber like cotton, silk, wool, synthetic fiber such as polyester, nylon and spandex. So, where there are the various weaving material. So, natural fibers are attractive for their biocompatibility, comfort and high surface area which promote the efficient electrolyte absorption and energy storage interface. Cotton in the particular have been carbonized to serve as a conductive scaffold for the active material, whereas synthetic fibers offer the advantages such as enhanced durability, water resistance and tensile strength, making them more suitable for the outdoor or rugged environment. Despite these benefits, several challenges limit the full potential of a textile-based supercapacitor. While comfortable and eco-friendly, natural fibers are often hydrophilic and leads to moisture absorption. So, they may degrade the device performance over the time. So, they can be suffer from the non-uniform coating due to their porous and the rough surface morphology that will affect the consistency in the conductivity and electrochemical behavior. Moreover, in the other hand, we are having the synthetic textile which is typically possess low surface energy, making it difficult for the conductive material. So, carbon nanotube, graphene and the conductive polymers to adhere without surface modification or chemical treatment, which can compromise flexibility or add toxic component. Another is a 3D spacer fabric have been also investigated as a viable substrate for supercapacitor application. So, 3D spacer fabric is a 3-dimensional textile with the two outer layer joined together but kept apart by a spacer yarn. There is a space between the arrangement of the fabric manufacturing, means it is prepared through the yarn, but there is a space between the binding of the yarn. So, spacer yarn act as a linear spring under the compression, influencing the compressibility of the spacer fabric. So, each layer of the 3D spacer fabric can provide the unique characteristics and providing the flexibility to the textile designer in terms of the functionality. So, 3D spacer is utilized as a reinforced material combined with the several matrices in the textile structural composition. Whenever we discuss about the fabrication of these devices, we will see that how we will use this 3D spacer to utilize in the development of the supercapacitor. So, spacer fabrics are utilized in a wide range of application when developed into the special textile products by modifying the fabric structure. So, for spacer yarn, polyester monofilament is chosen as it has good resilience and does not adhere for the for the magazine, ensuring the magazine only to the outsider fabric. So, preventing short circuit between the two outer layer that act as a electrode. So, we will discuss in the further lecture and we will see how this spacer fabric is used in the development of the electrodes. Thank you very much.